This time we have to draw a hyperbola and characterize it using a couple of key features given. And the features they're choosing to give us in this one are vertices and one of the co-vertices. So I think the easiest way, instead of worrying about what the equation is going to look like, I think the easiest way to deal with it is first, let's draw it. And what it's going to look like is this. You have your vertices here that I've put in purple, and once you put them on a graph, you can see they're vertically oriented, which means we have a vertical parabola, hyperbola. Now, that'll tell you where the center point is, and you can start off noting the center very, very easily. You just say the center is halfway in between the vertices. So that's going to be at, if I read my graph here, that's going to be at -1, comma 2. So -1 in x, 2 in y. And then we have one of the co-vertices given, which is at -6, comma 2. I've put that in orange, which means the other one's going to be simply reflected over the center of the hyperbola to the other side. And that's going to put that, well, if this is 1, 2, 3, 4, 5 clicks, then we go 1, 2, 3, 4, 5 more. This is going to be another co-vertex at 4, comma 2. Now, from that information, we have something very, very useful. For the vertices, we can see that B equals 2, right? The vertices are located 2 up and 2 down from the center. For the co-vertices, we can see that A equals 1, 2, 3, 4, 5, right? 5 to the left and right from the center. Now, that's really useful information because up here we're told we need to put this in standard form, right? So we've already gotten B and A, and from the center we have H and K. So we write this thing out now, just literally plugging things in. Remember, K and H we got from the center of this thing, which was located at -1, that's H, and the Y value was 2, that's K. We already talked about this below. A was 5 and B was 2. So what that means is A squared is 25 and B squared is 4. And when we put that all into our equation, we get this. Y minus K, so that's -2, over B squared, that's 4. And then we have minus, because this is a vertical hyperbola, that means Y is positive, X is negative. And the center at H equals -1 means we have an X plus 1 right here. Again, that's squared. And it's divided by A squared, so that's going to be 25. Equals 1 is our result. That is our standard form equation for the hyperbola. We've already talked about the center, right? That's just -1, comma 2. We've talked about the locations of the vertices, and well, the vertices were just given to us, right? That's easy. -1, comma 0, and -1, comma 4. We were given the location of one of the co-vertices. That was -6, comma 2. And the other one we found just looking at this picture, right? That was just on the right side instead of the left side. So that was 4, comma 2. And the foci we haven't talked about yet, so that will require a little bit of math. Remember what the equation is for foci. C squared equals A squared plus B squared. It's the Pythagorean theorem equation. So for this, we just say, fine, C squared equals, let's see, A was 25, B squared was 4, so that means C equals square root of 29. Now, because this is vertical, what that means is we go up and down from the center by that amount. So I don't know if this is the right place to put it, but it doesn't look too bad. We're simply going up and down from the center. So this is going to be, let's get the center again. Center, remember, is -1 in x, and it's going to be 2 plus radical 29. That's one of them. And the other one is going to be at -1, same x location, and this time it's 2 minus radical 29. Now, the equation of the asymptotes will take a little bit of thinking. So you have to remember how these work. We have a viewing window for this hyperbola that simply is defined by the co-vertices and vertices. There's this square right here. The reason I like thinking about it that way is because now it's very easy for me to see this diagonal line, that's one of the asymptotes, going up like this. And it has a slope that's given according to m equals rise, that's B, over run, that's A. For us, this means the slope is 2/5. And all we have to do now is plug that into the old slope-intercept form equation. y equals mx plus b for that asymptote going up and to the right. Well, the center point of this gives us our clue. Remember, x is located at -1, so m is 2/5, x is -1. I don't know what b is, but I do know that y is 2 at that center point. So I can just solve this equation for b. Okay, that's going to give me the following. 2 plus 2/5 equals b, which, if I'm thinking about this right, means b equals 12/5. Right, if I add those two fractions together. So now when I plug this in, I get the following equation for an asymptote. 2/5, that's the slope, times x, plus the slope intercept, or the y-intercept. That's 12/5. Okay? So that's how we find one of them. The other one, I'll put in blue. You can see that's going to be going down, like this. So it's the same slope of 2/5. It's just, now it's going negative instead of positive, right? It goes down by b and over by 5. So in this case, m equals -2/5. Don't get confused with perpendicular. These two asymptotes are not perpendicular to each other. They just have opposite sign slopes. So we plug this into the y equals mx plus b equation again using the center point. See the center point right here at -1, 2. So that means y equals 2. M is this -2/5 thing. X is going to be -1, and I have plus b. So this means 2 equals 2/5 once I cancel out the negatives, plus b, which means when I solve this, I'm going to get 8/5 equals b. And that means, here's my equation. y2 equals -2/5 x. Okay, and then I have plus that 8/5. And there's my two asymptote equations right here.